Commodore 64, one of the original home computers, but there's a lot of life left in that old machine. New software titles still coming out for what is still a very large installed user base.
Peeks and pokes. No, we're not talking about jabbing the computer, but we will be able to look around inside the machine and stick things in there. Just as variables could be thought of as a representation of boxes within the machine where you placed your information, you can also think of some specially defined boxes within the computer that represent specific memory locations. The Commodore 64 looks at these memory locations to see what the screen's background and border color should be, what characters are to be displayed on the screen, and where, and a host of other tasks. By placing, poking, a different value into the proper memory location, we can change colors, define and move objects, and even create music. These memory locations could be represented like this: 53,280x. Border color: 53,281y. Background color: 53,282, 53,283. On page 60 we show just 4 locations, 2 of which control the screen and background colors. Try typing this: POKE 532817. The background color of the screen will change to yellow because we placed the value 74 yellow in the location that controls the background color of the screen. Try poking different values into the background color location, and see what results you get. You can poke any value between 0 and 255, but only 0 through 15 will work. The actual values to poke for each color are 0 black, 8 orange, 1 white, 9 brown, 2 red, 10 light red, 3 cyan, 11 gray, 1 4 purple, 12 gray, 2 5 green, 13 light green, 6 blue, 14 light blue, 7 yellow, 15 gray, 3. Can you think of a way to display the various background and border combinations? The following may be of some help. 10 for 88 is equal to 0 to 15. 20 for bow equals 0 to 15. 30 poke 53280 BR. 40 poke 53281. Bow 50 for x equals 1 to 2000. NETX 60. Next 80. Next 88. Run. 2 simple loops were set up to poke various values to change the background and border colors. The delay loop in line 50 just slows things down a bit.
Slows things down a lot. Okay. I want to try something. I don't like it going so slow. I want it to go fast still. Let's turn this to 200. Let's go 20. There we go. 20's fast. Alright, let's try another one. Let's test it and try 200. Yeah, they could have put 200 in there, that would have been fine sense. Alright, let's stop that. Peek. Okay, so let's put this in brackets. 53280 in the bracket. And 15.
For the curious, try PEEK 53280 and 15. You should get a value of 15. This is the last value border was given and makes sense because both the background and border colors are gray, value 15, after the program is run. By entering in 15 you eliminate all other values except 1 to 15, because of the way color codes are stored in the computer. Normally you would expect to find the sum value that was last poked in the location. In general, PEEK lets us examine a specific location and see what value is presently there. Can you think of a one-line addition to the program that will display the value of back and border as the program runs? How about this? 25 print CHR $147, border equals PEEK 53280 and 15, background equals PEEK 53281 and 15. Screen graphics. In all the printing of information that you've done so far, the computer normally handled information in a sequential fashion. One character is printed after the next, starting from the current cursor position, except where you asked for a new line, or used the comma in print formatting. To print data in a particular spot you can start from a known place on the screen and print the proper number of cursor controls to format the display. But this takes program steps, and is time-consuming. But just as there are certain spots in the Commodore 64's memory to control color, there are also locations that you can use to directly control each location on the screen. Screen memory map. Since the computer's screen is capable of holding 1000 characters, 40 columns by 25 lines, there are 1000 memory locations set aside to handle what is placed on the screen. The layout of the screen could be thought of as a grid, with each square representing a memory location. And since each location in memory can contain a number from 0 to 255, there are 256 possible values for each memory location. These values represent the different characters the Commodore 64 can display, see Appendix Q. By poking the value for a character in the app row, pry its screen memory location, that character will be displayed in the proper position. Screen memory in the Commodore 64 normally begins at memory location 1024 and ends at location 2023. Location 1024 is the upper left corner of the screen. Location 1025 is the position of the next character. To the right of that, and so on down the row. Location 1063 is the rightmost position of the first row. The next location following the last character on a row is the first character on the next row down. Now, let's say that you're controlling a ball bouncing on the screen. The ball is in the middle of the screen, column 20, row 12. The formula for calculation of the memory location on the screen is point equals 1024 plus x plus 40 asterisk y column. Row, where x is the column and y is the row. Therefore, the memory location of the ball is 1024 plus 20 plus 480 or 1524 column. Row, 40 feet 12 inches. Clear the screen with registered and CIR/home and type POKE 1524, 81. POKE 55796, 1. Color memory map. A ball appears in the middle of the screen. You have placed a char actor directly into screen memory without using the print statement. The ball that appeared was white. However, there is a way to change the color of an object on the screen by altering another range of MEM. RE. Type. Location POKE 557962. The ball's color changes to red for every spot on the Commodore 64's screen. There are two memory locations, one for the character code and the other for the color code. The color memory map begins at location 55296, top left-hand corner, and continues on for 1000 locations. Same color codes, from 0 to 15, that we use to change border and background colors can be used here to directly change character colors. The formula we used for calculating screen memory locations can be modified to give the locations to POKE color codes. The new formula is color print equals 55,296 plus X plus 40 asterisk Y.
Commodore 64, one of the original home computers, but there's a lot of life left in that old machine. New software titles still coming out for what is still a very large installed user base.
It provides a real good hardware bed for software writers because they can take a software development cost and amortize it across these millions of units. The result is you get a lot of good software at a very affordable price.